Here are the answers for the section 8-5 assignment about ellipses. For question 1, we're asked to graph. So when you look at the equation of what you have to graph, it has a certain format that it's important you recognize. The x is squared and it has a denominator. There's an adding symbol in the middle. The y is squared and it has a denominator, and it's equal to 1. You need to recognize that this makes an ellipse. The general form that you're matching this up with is x squared over a squared plus y squared over b squared is equal to 1. This has this pattern. The square root of 9 gets us a equals 3. The square root of 4 gets us b equals 2. The a equals 3 is associated with the x term, so it's on the x-axis that you go 3 units to the left of center, 3 units to the right of center. The b equals 2 is associated with the y, so on the y-axis go up 2 and down 2. Then freehand draw in an ellipse, which is an oval shape. If it gets too pointed on the ends and it looks more like a football, just erase it and try to round those ends a little bit better. Number 3, we have the same basic look to it. X squared, y squared, plus sign in the middle, 1 on the right. But the thing that is different is that under the letter y is the larger of the denominators. So this time it matches x squared over b squared plus y squared over a squared is equal to 1. In an ellipse, because of the definition of what a and b are representing, a is always a longer number than b. So if this one here is the larger denominator, then it has to be the one that involves variable a. So doing square roots, we can see that b is 6 and a is 7. So the value of 6 is associated with x. So it's on the x-axis that you go 6 to the left and 6 to the right. The value a equals 7 is associated with the letter y this time. So go up 7 and down 7. And then draw in an ellipse. It's almost circular because we almost went the same amount in all directions. Number 5, we have x squared and y squared. We have a plus sign, but this is not general form for an ellipse because an ellipse has a 1 on the right. So let's divide everything by 100 to create that. 4 divided by 100 reduces to 1 over 25. Over here we have y squared over 100, and 100 divided by 100 is 1. Now which has the a and the b? This one's the b, it's 5. This one's the a, it's 10. So the center's at the origin, 5 left, 5 right, and then up 10, down 10. And draw in the ellipse. Number 7, it's got x squared, it's got y squared. So we're already thinking either circle or ellipse. But it doesn't say equals to 1. So let's divide by 4,900. This makes x squared over 100 plus y squared over 49. That's equal to 1. So a is 10 and b is 7. So now you can mark on your x-axis where the x-intercepts are, and on the y-axis mark the y-intercepts, and then draw in the ellipse. Number 13, this time we have an inequality, so let's expect some shading when we make our picture. This is a compound inequality. This would be a lot easier for us if we separated it into two pieces, piece number 1 and piece number 2. So for piece number 1, let's rewrite only one part of it. 9x squared plus 4y squared is greater than or equal to 36. For piece number 2, let's rewrite it again. 9x squared plus 4y squared is less than 144. I think these are both going to be ellipse shapes, but we need to make the standard form where there's a 1 on the right side. So in this one, divide everything by 36. This reduces to x squared over 4 plus y squared over 9 is greater than or equal to 1. Now for the other one, divide this one by 144. So it makes x squared over 16 plus y squared over 36 is less than 1. Let's graph both of these and then figure out where the shading goes. This first one has a solid boundary line because of this little line here on the arrow, and this is an ellipse where b equals 2 and a equals 3. So from the center, go left 2 and mark it, right 2, mark, go up 3 and down 3. We already said it's a solid line when you draw the ellipse in. This is a is greater than. Where do you think you shade? Outside the ellipse or in it? We're going to end up shading outside. But let's finish that shading later after we know where the other boundary line is. Okay, now the next one. This is also an ellipse, and we can see that b is 4 and a is 6. So on the x-axis, go out 4 and mark it, and right 4, mark that. Go up 6 and down 6. Now what kind of boundary line when there's no or equal to on the inequality arrow? It's dashed. So put in a dashed ellipse line. Where do you think you shade when it's a is less than? Do you think you shade inside the red ellipse or outside? That would be inside. So we want to stay inside the red dashed line, but we want to be outside the solid blue line. Where is that? And that's this donut shape. So shade that in. So it's kind of a weird shape, but that actually is more realistic to where people use algebra than a lot of the things we've talked about this year. Because in manufacturing, it's quite common to need to have a machine that would create a part that looks like that. Number 15, find the equation of an ellipse and sketch. And here's what we're given about the ellipse. Its focus points and its focal radii. Let's actually sketch it first and then make our equation. This will help us visualize what's going on. So 3, 0 and negative 3, 0 are both on the x-axis. Here's F1 at 3, 0. Here's focus 2. We're also told that the focal radii, which is 2a, is equal to 10. So from that, we can figure out a is equal to 5. From the center, if you go 5 units left, you can mark the end of the ellipse, and from the center, if you go 5 units to the right, you mark the other end of the ellipse. So sketching in the ellipse, it's going to go something like this. What's the thing that we don't yet know, but it's important that we do? We need to know the value of b to know how high up that y-intercept is right there, and how far down that y-intercept is. We need to know what b is to get that. Well, what do we have to work with? We've already figured out that a is 5, and we also know where the focus points are. So we know a, and we know c. Do you remember what c represents in an ellipse? It's the distance from the center to the focus, which is 3 units. In our notes about ellipses, we included a formula that involved b squared. It was b squared equals a squared minus c squared. So let's make substitutions. A squared is 25 and C squared is 9. This makes 16, and therefore B is 4. With the Pythagorean theorem, some of you knew already that that was 4, because a 3, 4, 5 right triangle is a really common right triangle. We now know that this dot right here is located at 0, 4, and that this dot is located at 0, negative 4. We can make our equation. X squared over A squared, so that's 25, plus Y squared over B squared, that's 16, equals to 1. For the review assignment, let's go back to page 211, and we had this kind of equation. We're asked to graph that. Well, what shape did this make? The letter y is alone and x is squared. That's a parabola. So you got to decide what shape you're trying to create before you start to graph anything. You need to know, is it a parabola, a circle, an ellipse, or maybe it's just a straight line? Let's rewrite this so the terms are in the correct order. And because this is in standard form, A is -1, B is -2, and C is 5. Now use the formula that gets x vertex. It's -b divided by 2a. So that's 2 over -2, which makes -1. Then substitute that to get y vertex. 5 plus 2 makes 7, and 7 take away 1 makes 6. Now we can make an xy table. And as the middle row, we figured out -1, 6. Counting backwards from -1 goes -2, -3. Counting forwards from -1 goes 0 and 1. When you substitute 0 into the original equation right here in black ink, the answer for y is 5. And because of symmetry, this will be 5. Now substitute in 1. 5 take away 2 is 3. 3 take away 1 is 2. And this will be 2. Now we can graph it. On my x-axis, the farthest left was -3, and the farthest right is +1. On the y-axis, we have to get up to 6. -3, 2 is here. -2, 5. -1, 6. 0, 5. And 1, 2. And then draw in the parabola. Number 4, we want to graph this. Let's figure out what it is. X is alone. X is a linear term. Y is squared. Which of the shapes that we've been studying lately is this? It's a parabola. And because X is alone, and this is negative, the parabola is sideways, opening to the left. Let's make an XY table to get dots. And put the vertex in the middle. Because there's a y squared term, but no y and no constant, the vertex is 0, 0. Counting backwards from 0, we'll use -1 and -2 for y. Counting forward from 0, we'll use 1 and then 2. Let's substitute these numbers in to see what x equals. Put in a 1. -2 times 1 is -2. And this will be -2 as well. Now put in a 2. 2 squared is 4. -2 times 4 is -8. And this will be -8. Now we can graph. Take a look at our x values. The farthest left it ever goes is to -8. 1, 2, 3, 4, 5, 6, 7, 8. Look at the y values. We got to go down to -2 and get up to +2. Now let's graph. Left 8, down 2. Left 2, down 1. 0, 0. Left 2, up 1. And left 8, up 2. Here's our sideways opening parabola. Page 308, we were studying circles. Write an equation of the circle. This again comes down to you knowing general forms. So for a circle, x minus h squared plus y minus k squared equals r squared. So let's substitute. X take away 7 squared. Now in here, y take away -1 squared. And then over here, the square root of 3 squared makes a regular 3. Because of the negative here, let's fix.